Hi, it's GCSE question paper 2 time. Let's smash this question on monomers and polymers. This question is about monomers and polymers. Compound A has an alkene functional group and an ester functional group. Figure 8 represents a molecule of compound A. So here you've got your two bits of the molecule there. We'll look at them in a minute. 8.1, draw a circle around the alkene functional group on figure 8. So we know an alkene functional group is a carbon-carbon double bond, and here it is, 1 mark. Easy peasy. 8.2, describe what we'll be seeing when compound A is shaken with bromine water. This is for 2 marks. Now, bromine water goes from orange to colourless in the presence of a double bond. So to get our 2 marks, the orange of the bromine water will turn colourless or is decolorized. 1 mark for orange, 1 mark for decolorized. 8.3. Figure 9 is a repeat of figure 8. Draw a circle around the ester functional group on figure 9 for 1 mark. Now we know an ester is a carbon to double bond oxygen, carbon single bond oxygen. So if you look there, there's our carbon, there's our single bond, double bond oxygen, 1 mark. 8.4, compound A has the formula C4H6O2. Compound A is flammable. Write a balanced equation for the complete combustion of compound A for 3 marks. So let's put in our compound A formula, C4H6O2. O2, because it's burning in oxygen, it's in complete combustion, so there's loads of oxygen. We're going to get carbon dioxide and H2O for our products. So let's start balancing. We always start with the carbons, 4 carbons there, so we put 4 carbons there. We're doing all this in pencil, so we can rub out anything that we don't need. So if we try and balance in the 6 hydrogens, that gives 3 H2s. So now we've got our balancing on the right-hand side, just got to get those oxygens balanced. So we've got 4 2s are 8 oxygens and 3 oxygens on the right. I've got 2 oxygens in compound A, so we need 9 to make 11 equal with the right. So we can't put 9 O's because it's O2. So we have to halve that, which makes 4.5, which doesn't fit. We don't have halves at this stage. So let's just drop those down, the 4.5, the 4 and the 3. And the simplest way is to double everything. So double compound A, so that makes 9 O2, 8 CO2, and 6 H2O. And if you look up and count all those up, that balances for 3 marks. 8.5. Many molecules of compound A join together to form polymer B. Complete the displayed formula equation which represents the reaction for 3 marks. 2 marks, beg your pardon. Well, look, there's a carbon-carbon double bond, and that opens up in polymerization, and you end up with a single bond, and then you get those 2 half bonds sticking out the side of the brackets. So that double bond becomes a single bond for 1 mark. This N means a large number of monomers, 10,000 plus. So that N goes on the right hand side of the bracket there to say there's 10,000 of those repeating units. 2 marks. 8.6. What type of polymer is polymer B? Tick 1 box. Well, if we go back and have a look, what we can see is all these monomers add together. There's the key, it's addition. Addition polymer, 1 mark. 8.7. Polymer B is a polymer which melts when heated. What word is used for 8.7 to describe polymers which melt when heated? Now, if something melts, it goes soft. So that's a key, isn't it? The answer is thermosoftening for 1 mark. 8.8. Explain why some polymers do not melt when heated for 2 marks. This is all about crosslinks. Some polymers, some polymer chains have covalent bonds, strong covalent bonds joining them together. And this makes them very strong and very resistant to temperature. So there are cross links between the polymer chains. Therefore, too much energy is required to overcome these cross links. 1 mark for cross links, 1 mark for too much energy, 2 marks. Bingo!